Hello, everyone. Welcome. Thank you for coming. My name is Martin Odersky. I work for Originate, and I'm going to talk today about what's new since programming in Scala. So programming in Scala is the definitive book, the definitive reference guide on Scala. I believe it is the book that most of us have used here to learn Scala, by Martin Odersky, who is right there today. And Lex Spoon and Bill Venners, the three authors. And the only problem is that the book's getting a little old. The first edition came out in December 2008. It would cover just Scala 2.7. The second edition came out in 2010, covers Scala 2.8. And we have some pretty big releases since then. But unfortunately, the third edition of the book didn't come yet to show us all the great new features that we have in Scala. So Bill Venners loves me. Every time I see him, he tries to run away and hide. And actually, if you look at the picture, I am his screensaver. You know, he said I'm there to scare him so he can finish the book and get some time to finish the book. So this is true. This is Bill Venners. So let's have a quick look at the Scala timeline here. So Scala was released in 2003, version 0.8. I don't know what happened with the versions before that. In 2004, we had version 1.0, followed by a lot of new releases. 2005, we have 1.4. And finally, in 2006, Scala 2 came out. And the great feature about Scala 2 is that Scala C was now finally written in Scala itself. So a self-hosting compiler. We all know that this is a very important milestone to reach. 2007, we have a lot of more versions. And then the Lift web framework was released. This is, as far as I know, the oldest big Scala project that we have. So in 2007, 8 years already. 2008, we have 2.7. 2010, we have 2.8, which was a very important, very big release. And also in 2010, Play 1.1 was released with a Scala support via plugin. So at that time, the Play framework was written in Java, but it started to support Scala with a plugin. And also the Akka framework was released in 2010. Finally, 2011, we had Scala 2.9 and the creation of TypeSafe. The company was founded in 2011. 2012, Play 2 moved to native Scala, so now the situation was reversed. Java was the second class seats, and the framework was written in Scala. Scala was native. In 2013, we had 2.10. In 2014, we had 2.11. And 2.12 is not expected before 2016, so next year. Okay, so a quick reminder here what was new in Scala 2.8, because 2.8 was a very important release. It had a huge number of bug fixes with respect to 2.7 and an impressive amount of new features. This comes from the release notes. Redesigned collection library was the flagship feature. The can build from, it's very popular on Stack Overflow. There's a question about it, very popular. So this is when can build from was introduced. We had name and default parameters, which allowed us to have the very useful copy method for case class. We had package objects, nested annotations, type specializations for box primitives, Java converters, which is explicit implicit conversion from Java to Scala, so it doesn't happen automatically. You have to call as Java and as Scala, so it's safer to use than to use Java conversions. And the REPL had some improvements with enhanced tab completion, searchable history, just like in the shell. And Scala Doc 2 with a new look and feel, and you could use a weak-like syntax to write your Java, so your Scala docs. You did not need to use HTML tags for that anymore. And finally, for the first time ever, binary compatibility for minor revisions. So 2.8.1 was compatible with 2.8.0, which was compatible with 2.8.2. So it's not ideal, but it's already a very good step in the right direction. So let's see what is new in Scala 2.9, 2.10, and 2.11. Okay? And if something isn't broken, Scala 2.10 will fix it, because that was a really, really big release, in my opinion, which brought a lot of new features. First thing that is DelayedInit, a trait that's deprecated now, actually, and the app trait. So what that means is the reload word example that we have for Scala is something like that. We have an object reload that extends application. And the problem with this trait that we're extending here is that the print line is part of the constructor, and the JVM will not optimize the constructor. It would not be thread safe. So people were writing applications that could not be taking full advantage of all the performance optimizations that the JVM has to offer. So it was not thread safe, not optimized. And now the app trait doesn't change anything. You just have to delete a few short string, looks the same, behaves the same, but now you have all those benefits to you. And in addition to that, you have the command line arguments are accessible via vol args to you. So we have lies, damn lies, and benchmarks. So I'm going to show you here a pretty bad benchmark, but it's at least can give us some idea. I'm just summing out the numbers from 1 to 4 million. I'm going to run twice just to see if the JVM kicks in some optimization. And here's the same code, but instead of extending application, I'm extending app. And when I run application, it takes about 7 seconds to run. But when I run app, it takes 7 milliseconds. So 3 orders of magnitude difference. And I thought, well, this is not right. Probably the JVM is optimizing away my loop. Because I'm not doing nothing with the results. Let's try something different. So I replaced the for comprehension with a while loop. And again, it's the same thing, just extending app. And those are the results that I had when I was using the for comprehension. And these are the results that I have when I'm using a while loop. And this is interesting. So we can compare vertically and horizontally here. So when we compare horizontally, we see that, yes, the while loop used to be faster than the for comprehension. But when we are using the app now trait, there was not a lot of change. You know, it's still faster than the while loop. It's still faster than the application trait, but it's the same as before, which brings us to the next nice feature that there is now in Scala 2.10, we had a range for each optimization. Okay, so in the words of Paul Phillips on the Git commit there, makes code like 0 to 100 for each, as fast as, often faster than a while loop. So there is this misconception that for comprehensions are slow, and this is just not the case anymore. Scala 2.10 fixed that problem. Parallel collections. So parallel collections were the flagship feature for Scala 2.9. It was an effort to facilitate parallel programming by sparing users from low-level parallelization details while providing them with a familiar and simple high-level abstraction. And really, this is an understatement because parallel collections could not be simpler and easier to use. So it's efficient and transparent. You have 2 methods now, .par and .sec. You call .par on a sequential collection, and then you get a parallel collection, and you can use it the same way you could use a sequential collection. Depending on the collection, this may even be a constant time operation, okay? Because the data set is shared between the parallel and sequential collections. And when you have a parallel collection and you want to get back a sequential collection, for that it's always constant. And those are the collections that do support parallel operations. One was introduced in 2.10, actually. Okay. The thing to keep in mind that parallel collections, they have obviously concurrent out-of-order semantics. So the order in which the functions are applied to the element, it's arbitrary. It's not deterministic. We don't know it, which it will be. Which means that side effects are prone to race conditions. Okay. And side effects and associative operations can lead to non-determinism. And non-commutative operations, however, are deterministic. So what I mean here, it may be a good idea to refresh. When we have something that is associative and commutative, it's an operation like addition. Because 1 plus 2 plus 3 is the same as 1 plus 2 plus 3, and it's the same as 2 plus 1 plus 3. So this will work with parallel collections. Something that is associative but is not commutative is the string concatenation. So A and B and C is the same as A and B and C. They produce the same string at the end. But if I try to concatenate B and A and C, I will not get the same result. This also works with parallel collections. Okay, so it's associative, but it's not commutative, but it still works. What will not work is something like subtraction, because it's not associative. And subtraction just so happens to also be non-commutative, but this doesn't matter. It's just associative that you should be worried about. Again, I'm going to lie to you again with a benchmark here. This is a code that fills an array, a vector, actually, with 50 million random numbers, and then I just to make the JVM do some work, I try to see if the square root of a number is there. If any of those numbers, the square root of them matches a target. An artificial thing just to give the JVM some work. And this is the sequential version. This is the parallel version. Can you see the difference? Okay, I just add a dot par at the end there. So just 4 keystrokes. And let's see the difference that it made on my computer. The sequential version took 400 milliseconds. And the parallel version took 100 milliseconds. So linear scalability took 4 times faster on my quad-core computer. With 4 keystrokes, you can't do better than that. You know, this is really awesome feature in Scala. And now we have a generalized try-catch finally. So what that means is that you can reuse your exception handling. So now we have a try, takes a body, a catch takes a handler, and then finally takes a cleanup expression. And what's different here from Java is that body and cleanup can be any expression you want to pass, and handler is a partial function from throwable to T. So what I can do is I can define a default handler, like I'm doing here, and then it doesn't matter where my exceptions are. I do not need to write those case statements anymore to catch all the different exceptions. I just pass the handler to the catch block. So this is a really awesome feature, but unfortunately it's pretty useless. And why I say that is because we should not be using exceptions. Okay? In Scala we should not be using exceptions. Don't look so oh God. Don't look so ugly to me. We should now use exceptions in Scala code, okay? Because exceptions are not functional. Functions that throw exceptions are not total functions because they do not return a value for all possible inputs, okay? They are not defined for all possible inputs, so do not try to catch exceptions. Try to catch exceptions, okay? So, yeah, of course, I'm joking. It's not useless. Try catch still has its use, but you probably should try to use try. No pun intended. So try was introduced in 2010, and it represents a computation that may either result in an exception or return a successfully computed value. So this is the way I like to see it. Tries those for exceptions, what option does for null, okay? So I don't think I need to teach anyone here about option, about null. Everyone is using, embracing options, and try are the same thing for exceptions, you know? So it's used to perform operations without the need to do exception handling in all places that an exception might occur. And so you have an instance of try, just like option, we have some and none. For try, we have success and failure. And only non-fatal exceptions are caught. System errors are still thrown, so this is the expected behavior. And Of course, they have methods like map and flat map, so they can be combined in 4 comprehensions. And they also have recover and recover with, that it's just like map and flat map, but for failures instead of success. And everything else that you would expect for the things that are monad-like. So here's an example of how you can use try. I have a method that takes 2 strings, try to convert the strings to integers, and then try to divide one number by the other. And if I call something like divide A by 0, it's going to throw a number format exception. And if I try to call 1 and B, it's going to throw a number format exception, but I can see where that came from. The first line came from the A, the second line came from the B. So you still have access to all that information that you need for proper logging and error reporting. And if I try div 1, 0, I'm going to get a arithmetic exception just as expected. Okay. There are some very useful methods that try gives you, like 2 options. So I don't care about the error. You know, if something failed, I'm just going to return a none. 2 options is very convenient. Or if something failed, I don't care about the error. I will send back a default value. And now there is one here that I really like. I think it's really useful. It's get. So if the computation performed correctly, get's going to return you the value. But if it does not, it's going to throw an exception. And you say, how can this be good? The thing is, we are used to never use get on an option because on an option they are bad. They're going to throw an exception. But here they can be very useful. Let's say that you have an API. You have already some code base. And this code base was created before Scala 2.10, and it's throwing exception everywhere. You cannot change the API just yet. That would be a big refactoring. But you do want to use try for new code. So what you do, you write your method with the same old signature that you had before. You put it inside the try, and at the end you put a .get. So it's going to behave exactly the same as you would if you are not using the try. And when it gets time that you can finally convert the method to return a try, you just delete the .get and everything is done for you. So I think try.get, it's different from option.get in the sense that try.get is really useful when you're transitioning your system. Value classes, implicit classes, and extension methods. So implicit class are a more convenient syntax for defining extension methods. They are classes that have a primary construction with just one parameter. So this is an example in implicit class A that has a parameter int. And they are desugared into a class in an implicit method pairing. So it's basically what you would do before with an implicit method conversion. Because of that, because you have to define a method with the same name, case class cannot be implicit. And here an example of how you could use it. You can create a class int ops and define a method stars, and then I can call 5 stars. And I have a string with 5 stars. Value classes. Value classes are used to avoid object allocations. Some conditions apply. It's not always that you can truly avoid allocation. And they give you the type safety of a custom data type without the runtime overhead. So this is great for things like temperature. You know, you don't want to mix Celsius with Fahrenheit. For weight and height and first name, email. First name and email are strings. You don't want to mix them. Age is an int. You don't want to pass any int as an age. So you wanted them to be more type safe. So again, they have only one primary construction, which is actually one vol parameter. Only methods. You cannot have any other kind of members on those classes. And they may not define equals or hash code and cannot be extended by another classes. So here is an example. I have a case class age. So a value class can be a case class. Extends any val. So this is the syntax that you use. You just put extends any val to define a case value class. And when I create my age, at compile time, age is of type age. Okay? But at runtime, it's just an integer like any other. But I cannot call age plus 1. This will give a type mismatch error. It will not compile. And the cool thing is that you can combine both. an implicit class with a value class, and you have extension methods. And this is it's different from implicit conversions because they are location free. And they are somewhat equivalent to use an object with a static help methods. Okay? And it's just a simple mechanical transformation performed by the compiler. So if I have an implicit class, like I showed on the first example, this would be somewhat equivalent to creating a new instance of an int_ops object, and then calling the stars method on that object. And then this object just gets garbage collected because it's not going to be used anymore. While if I use an implicit class with a value class, this would be somewhat equivalent to having an object int_ops that has a method stars that takes an integer, and then the compiler would convert 5.stars to int_op.stars.5. So you're just calling a static method on an object. It's a lot faster on the JVM. There is no object allocation. String interpolation, 210 again. This is one of my favorite features. So you can just have a string, you put an interpolator before the string, and then you can use the dollar notation that is very common in many dynamic languages. But you can also use any expression you want, like I can have 2 plus 2 here to be evaluated inside my interpolator. And it worked with triple quotes. And very sorry that syntax highlighting is not working there. But you see that I have a template, and I can have multi-line string interpolation. And of course, to escape the $, you use a double $. Now, so far so good. This is no different from any dynamic language that has a similar feature. But Scala goes far beyond that. So there are some things that I have never seen in any other language that just Scala gives you. So the first thing is formatted strings. So instead of using the S interpolator, I'm going to use the F interpolator. And now I can pass a formatting string, and my string will be formatted instead of just interpolated. But the really, really cool thing is that it's type safe. So if I try to format with %d, it will give an error because what is required for % is an integer and trying to pass a double. So it's type safe. This happens at compile time, not at runtime. So when you compile the code, it's going to say to you that your string is wrong. Okay? And you can define custom interpolators. You can define your own interpolators. So there are just about a dozen frameworks that give you a SQL interpolator, a JSON interpolator. So how are those interpolators different from just the S interpolator? So a SQL interpolator, for instance, may escape your string, so you do not have a SQL injection. A JSON interpolator may recursively serialize your object. So let's say that foo is not just a string, it is itself an object. So that object would be interpolated, serialized to JSON and then interpolated here. I would not just call foo.string. So this can be very powerful. Future and promise. They were introduced in 2.10 and then ported back to 2.9.3. So future is a way to perform many operations in parallel in an efficient and non-blocking asynchronous way. Future is a placeholder for a result that does not yet exist, but may become available at some time in the future. It has callbacks like onComplete, onSuccess, onFailure that will be executed eventually. And the order in which the callbacks are executed, it's not deterministic. And they may not be called sequentially, but they may be even executed concurrently. So if you have more than one callback, those callbacks can be fired in parallel. And again, they have all sorts of methods there, like map and flat map, that allow you to combine them in 4 comprehensions. Okay. One thing to be aware, though, is that you have to be a little careful when you're combining features with 4 comprehensions. This is a very common mistake that I see people doing. I have a very simple feature here that I'm defining. It's just going to print when it starts, when it ends, and going to sleep in between. And it's very common for you to see people write something like that. So for A, B, C, and I'm creating 3 futures here. It works, but the problem here is when you run, you can see that R starts and A ends, B starts and ends, C starts and ends. Because what happens here is that I'm calling A flat map, B flat map, C map. So B will not be created before A ends. Okay? So the way to work around this problem is to create the features first, assign them to vals, and then use the vals in your for comprehension to combine them. Of course, as long as you do not have dependencies between the features. If feature B does not depend on the result of feature A, of course. And if you run that, every time you run, you're going to get a different result. You may even have some feature ending here before another one starts. This was just one particular run. Yours is going to be different. So a feature is a read-only placeholder for a result which does not yet exist. A promise is a writable single assignment container that completes a feature. So you create a promise. That promise will give you a feature. We can assert that the feature is not complete yet. And then I fulfill the promise. The way I fulfill the promise is I call the success method there. And then the feature will be completed. Just a final note here. When you work with features, it's going to be very common for you to end up with something like a sequence feature. And a sequence feature is not really very useful for you to handle. Usually what you want is a feature sequence. So there's this method, feature.sequence, that will take a sequence of features and convert it into a feature sequence. That is a lot more useful for you to use in a practical way. The dynamic trait, still 210. So it's just syntax sugar. Okay? It's a simple mechanical transformation performed by the compiler. It's not any sort of dynamic type. Scala does not have dynamic type. It's not any sort of optional static typing, nothing like that. It's to enable you to write flexible DSLs and convenient interface with dynamic language and data formats like JSON. And what it is you have your class, you extend dynamic, and you have to implement at least one of those methods, and then the following transformations are going to be applied. So if I have full.bar and my class full does not define a bar member, the compiler will convert this to a method called full.selectDynamic, passing bar as a string parameter. And then we have basically all possible combinations here. We have assignment to array, we have accessing a method, passing named parameters to the methods, and even mixing named parameters with something else. So it's very powerful, I think, very useful for dynamic language. Okay. Akka actors, 210, so the default Scala actors were deprecated. Akka is now the default actor library. And really, the migration notes here is just too long for me to cover. I'm going to refer you to the guide if you want to know the details, but probably you should know by now. Modularization. So some of the more advanced language filters now have to be explicit enabled. And the way you do it is to import language.x, and where x is one of those things there. So for instance, to use the dynamic trait that I just showed you, you have to either call Scala C-language dynamics or import language dynamics. You can also use the underscore to enable all of them at once. I would not recommend that. And implicit conversions is only needed when you're defining new implicit methods, for conversions. It's not needed for using one that already exists, and it's not needed if you're defining an implicit class. So this tells us that we should really be migrating away from implicit methods to implicit classes. That's the way to go with the language now. Reflection macros and quasiquotes. It was introduced in 2010. It's marked as experimental. And what is meant by experimental, in case you don't know in Scala, when they say that something experimental, it's not that it's unstable. It's that the API may change in a breaking way from one version to another without deprecating it first. So you may have to fix your code if you go from 2.11 to 2.12. It doesn't mean that it's unstable. So with macros, Scala can finally throw runtime errors at compile time. No. So it's used for metaprogramming, programs that modify themselves at compile time. I'm going to use that for code generation, some advanced DSLs. So at compile time, you have macros, and at runtime, you have reflection. And why we need to have a Scala-specific reflection is that because Scala has some elements that are just not available under the JVM reflection API. So we need something more there. And this gives us access to reified Scala expressions, so without using the manifest. Quasiquotes were introduced in 2.11, and they are a significantly simplified notation to manipulate Scala syntax tree with is. So a quasiquote is a string interpolator. So you see the power of string interpolators here. And what I do, I use the Q interpolator, and I have an expression like foo plus bar. And this gets converted to abstract syntax tree. So I can compare two different syntax trees to see if they have the same structure. So foo plus bar is the same as foo dot plus parenthesis bar. So it doesn't matter if I'm using infix notation, method notation, they both get parsed to the same syntax tree, and this is what the quasiquote is showing us here. They have the same structure. They are the same syntax tree. And they can be decomposed via pattern matching. So this starts to get really interesting. So if I have a val q foo plus bar, and I have an expression q 1 plus 2 times 3, foo will be assigned to 1, but bar will not be assigned to 2, will be assigned to 2 times 3. Because what I'm doing here is going not token by token, but I'm comparing syntax trees. So on the left-hand side, I have the plus at the top with 2 child members, foo and bar. And on the right-hand side, this tree would be the plus at the top. The left child is 1. But the right child itself is another tree. So this is the tree that gets assigned to bar, not just the token tree. And again, we can make sure that they have, it's equivalent to any other syntax tree that was supposed to produce the same result. Let's show you an example how to use this. So let's say you have a logger, and this is a very common idiom. You have if logger enable logger.log, and you're going to pass a message because you don't want to be calling the log method if it's not enabled, because this message may involve some computation, may be a little expensive to compute the parameter to the log method. Ideally, we don't want to be so verbose. We would like to call just log, we have a problem, and not have to deal with that, with putting a if word around the log statement. So the way we implement this macro is that we create a method log that takes a string, returns unit, and we say that this method is going to be implemented with a macro. This is the name of the macro, log imp. And here's what the macro looks like. We can skip the method signature, not very important. What I want to show you is the string interpolation that is happening there with the Q interpolator. And what I'm doing is just writing Scala code and interpolating values just like we do with HTML templates. So it's as easy to produce a Scala code as it's easy to produce an HTML page that we are all used to doing. With HTML templates, we have now Scala templates that you can generate code just writing the source code into your string interpolation. Okay. A few examples that use that is the play.json API. It's used for serialization to and from JSON. It's type safe. It has no runtime reflection. There is no bytecode enhancement. Everything happens at the compile time. very efficient, and it gives you to JSON and from JSON methods if you pass a case class to the macro. Scala pickling, it's a fast boilerplate-free serialization framework, so very similar to play JSON, but more general and broad. And it's about the same. You have pickle and unpickle methods here that will serialize for you using Scala macros, everything happening at compile time, no runtime overhead. Case class with more than 22 parameters was introduced in 2.11. You should not need it, but if you do, they are here. I could not come up with a meaningful example, but they are here. It's good to know that we can use them if we want. New methods in collections. This is by no way an exhaustive list. We have methods like contains, an option that is very useful. Fold, it's a type-safe alternative to pattern matching and using map, get, or else on an option. Permutations and combinations, you have no idea how much that saved me on job interviews. Just to be able to call permutations and combinations. Okay, SBT incremental compilation. So now Scala compiles 10 times faster with incremental compilation, but your build time is going to remain the same because the save cycles are being used to mine Bitcoins. It was introduced with 2.11, SBT 0.13.2. You just put this in your build SBT, and so some piece of anecdotal evidence. I measure on my projects, real projects in production, recompilation speed improvements from 25 to 80%. And the good news is that the bigger the project, the better the improvement. I got 8% speed improvement on my biggest project, the one that was taking longer to compile. So it's not insignificant, something that I really recommend if you're not using it, that you should put this line in your build SBT right now, but of course your mileage may vary. Predef dot exclamation question mark, question mark, question mark. This is actually more useful than I thought at first. It's just a placeholder for methods that are not implemented yet. And it's very useful for test-driven development. You just put a method and you put the triple quotes and then you're going to write your test first. Code samples, presentations, blog. Let's say you have to extend a class. It has some abstract methods and you're in a rush. You do not need those abstract methods right now. So you just put triple quotes and you implement the method that you're worried about. And when you have time, you come back later and finish your class. So you just do that. Put triple quotes, and of course, if you try to call the method, it's going to give you an exception. REPL colors in 2.11.4. So if you call Scala-G Scala.color, your REPL now is going to be like a rainbow. It's not full syntax highlighting, but it's nice. It's something. It does show you the variable names and the types in different colors. So Scala 2.12 and beyond. And we all watched the keynote yesterday, so I really there's no reason for me to be talking about this here. Java 8 support. We're going to be using Java 8 closures and lambdas, streams and functional interface. Bidirectional interoperability between Java and Scala. You can call Java lambdas from Scala. You can define lambdas in Scala that will be called by Java code, and which means that from Scala 2.12, just Java 8 is going to be supported. Martin talked about this yesterday too. So lazy vols, there are some problems with lazy vols. They may deadlock, even if there is no circular dependency between them. They may still deadlock when they're initialized. So this is being worked on. Okay, so lazy vols are the sausage of Scala. They look delicious at first until you learn how they are made. Spores are safer closures for a concurrent and distributed environment. There's a talk now from Heather Miller, and I believe it's about this. I miss it at Scala Day San Francisco. I'm missing it again. So, async and await, so two macros that make combining features simpler and easier. So that slide that I showed you how to define the features first, assign them to vals, and then combine the vals using for comprehensions. We have those two macros that do simplify this a little bit. You do not need to go through that verbosity again. There will be some cleanup on the library. Scala method, lots of talks here about it. A compiler-based code style checker. Is it still planned? I didn't heard more about it. Yeah, okay, awesome, good. Some things will be deprecated. This was also mentioned yesterday. Procedure syntax, XML literals. Okay, you're going to have to use XML string interpolation now. Scala swing and Scala continuations. I believe those are long deprecated already. And of course, we have Scala.js, the new platform, very awesome. And the Scala compiler forks, we have Dotty. Type level has a compiler fork now. Paul Phillips created one, which reminds me of Oppenheimer, who said that the Nobel Prize in Physics should go to the physicist who does not fork the Scala compiler this year. Okay, so a few references. This presentation is available online. Some of the things I talked about here, they are on our blog. All the release notes and all the documentation, if you don't believe me, if you don't trust me, I have a reference here for you. You can just grab the slides online and click. I want to say thank you, but before I open the floor to questions, there is a little announcement. I'm organizing a Scala conference in Canada later this year. It will be officially announced by the end of this week. We didn't want to clash with Scala Days. It's the first Scala conference in Canada. Martin, I would like to invite you to be a keynote speaker. If you have never been to Canada before, it would be a pleasure. But you can follow us on Twitter. It should be announced by the end of the week. Yes.
I had a question about the format substitution model. Mm-hmm. Can you use a locale with it? I couldn't click a locale to the formatter.
You mean when you have the vertical bar?
You have used the add function for a string, and you will have, for instance, double.
Oh, okay. Not sure. How you pass a locale? That's a good question. Not sure. No.
Okay, I just use the function. Okay.
Yeah, but good. Yeah. Make sure. I believe this is when it gets compiled, the macro converts it to Java format. I may do a research. It's a good question. I'm sorry, I don't have the answer for you right now.
Maybe it could be implicit.
Maybe, I don't know, since it's a Java API, maybe, I'm not sure. I'll investigate and get you the answer. Yes?
I would like to ask about this futures combining because and the for comprehension. I know you mentioned that it makes a lot of trouble for especially newbies who are not reading the documentation on it and docs on it. Probably doc is written that you have to first and things like that. But I'm just thinking about the situation because anyway, this computation is better. Yeah, this yielding to this A plus B plus C, it is better. Maybe we would add in Scala something which solves it. I mean, which resolve this for comprehension first by initializing the strings and then yielding the stuff. This would be maybe somehow similar to what we have in case of sequences. Yes, we change the sequences of futures into future of sequence.
Yeah, I have a friend who's really pushing me to write a macro to do that. So yeah, I think we could write a macro that would, you could call something like for concurrent, and then it would take care of initializing the features first for you, before trying to compose them. Yeah, I think you could solve that with a macro. And this was suggested to me before.
And continuing Eric Meyer wrote something that's called observable, and say when you have a sequence, and instead of using the sequence of futures, you can use this observable, and going to and somehow get it into Scala or something to be done closer to Scala.
Yeah.